Program in support of science education, Ciba Geigy is pleased to present this issue of the Science Screen Report.
The Science Screen Report. Developments in science, engineering, and medicine that help solve the problems of modern life. Across North America, use of solar energy is increasing, providing heating and cooling for homes, supplying energy to farm buildings, irrigating crops via solar-powered pumps, and warming water for use by industry. What you're seeing is the world's first commercial solar electric power plant. It's called Solar One. Now operating near Barstow, California, Solar One's kilometer-wide circle of mirrors, the area of 75 football fields, produces 10,000 kilowatt-hours of electricity, enough for a town of 2,500 homes. In the past few decades, solar energy research has been a major focus of worldwide scientific activity. By the early 1970s, the National Science Foundation supported the building of a large-scale solar electric power plant. A kilometer-wide field of computer-controlled mirrors called heliostats would track the sun and reflect its energy to a central tower-mounted receiver. Superheated steam from this receiver would drive a turbine generator producing electricity. Evaluations of components for this power plant, Solar One, were carried out at Sandia Laboratories near Albuquerque, New Mexico. The goal, a system both efficient in energy collection and adaptable to mass production. The computer-controlled heliostats track the sun from dawn to dark, then rest face down to minimize the effects of morning dew and wind-driven sand. Facilities include a 60-meter receiver tower and a collector field of 222 heliostats. Here, they are used to test prototype Solar One heliostat designs, like these two-pedestal maximal surface mirrors. The final heliostat design must have optimal initial cost, minimum maintenance cost, and maximal performance. Special high-quality mirror glass reflects 90% of striking sunlight from its slightly concave focusing reflector. TV cameras and heat sensors focused on the tower measure the energy reflected from a target zone below the receiver. As at Solar One, a computer then redirects each heliostat to focus on its assigned zone on the receiver. Computer graphic images display temperatures across the zone. The solar energy receiver is made of 24 sets of water-carrying tubes. Their heat-resistant alloy can withstand temperatures ranging from freezing to 1,000 degrees Fahrenheit. The receiver water tubes are also tested. These are coated with a special black paint which absorbs maximal quantities of heat. Receiver sensors report tube temperatures to a computer. Water flow is then adjusted to carry off the heat, maintaining the system's steam temperature and pressure levels. Besides projects like Solar One, photovoltaic cells, which convert sunlight directly to electricity, and other sun energy systems are also being developed. After statewide surveys, a location with dry, high desert terrain and very clear air, Barstow, California, is chosen as the site for the Solar One power plant. Construction commences in the fall. The outline of the solar plant graded into the sand. The plant site in the Mojave Desert averages over 300 cloudless days per year. Heliostats are arranged along north-south and east-west axes. From any site in North America, the sun appears always in the southern part of the sky, moving from east to west. In winter, it makes a low arc, so days are short. In summer, it makes a high arc, so days are long. Spring and fall arcs lie between. For this reason, most Solar One heliostats are located north of the east-west line to catch maximal solar energy as the sun arcs across the southern sky. Because of their reflection angle, mirrors south of the east-west line deliver less sunlight, so fewer heliostats are sited there. In spring, installation of heliostat foundations begins. Computer studies determine their pattern, placed to minimize distances from the receiver, and so maximize the energy delivered to it. Heliostats are also far enough apart to pivot and tilt freely without blocking each other. Unlike conventional fuels, solar energy is a continuous flow and not a finite, limited stock. A billion years from now, the sun will still be radiating free, dependable, and abundant energy to Earth. Any variations in solar energy are seasonal and regional, and can therefore be anticipated and planned for. The Solar One plant is expected to establish a benchmark in solar electricity technology, the first large-scale harnessing of the sun's energy for production of commercial electric power. In operation, each of Solar One's field of 1,818 computer-directed heliostats reflects sunlight to the tower-mounted boiler receiver. Atop the 75-meter steel tower, the receiver heats water to steam, shown in red, to drive a turbine generator at its base, producing electric power for the local energy grid, signified by the white arrows. After expanding its heat energy in the turbine generator, the steam is condensed to water, shown in blue, which is pumped through the receiver again. Once more, this water flashes to superheated steam at 1,000 degrees, continuing to drive the turbine generator. The heat from the receiver may also be delivered to an energy storage system. In this system, the steam is piped to heat a stored fluid, which is pumped through a tank holding several tons of rock and sand, which retains this warmth. The colder fluid at the tank's bottom is pumped past the steam tubes, which heat it again, and then passes into the top of the tank. Over time, the volume of hot gravel increases, storing more and more energy. To tap tap this stored heat, the now hot fluid is pumped through another heat exchange, converting cool receiver water into steam, which then drives the turbine generator in the usual way. On sunny days, this energy storage system is fully charged by sunset, allowing Solar One to generate 7,000 kilowatt hours of electricity for 4 additional hours. Sufficient energy is reserved for startup the next morning, whereupon Solar One returns to its normal 10,000 kilowatt hour power level. Solar One test period operations extend through most of the 1980s. It's designed to operate for 30 years, that is, until 2011 AD. During that time, Solar One will serve as a test facility for future solar electric power plant designs, ranging from 1,000 to 300,000 kilowatt hours. In addition, it will field test small-scale power generation systems designed for use in remote areas. Solar hardware developed here also will be applied to industrial process heating, solar-powered recovery of oil, and combined heat and power or cogeneration systems. Historically, new energy sources have required heavy subsidies until they could compete with older in-place systems. Once, hydroelectric power plants were new and expensive. Today, their initial investment is history, but they continue to produce fuel-less power. And every good water year, the real cost of the electricity they generate drops a little more. Similarly, solar power, like other renewable systems now being tested, will have an important stabilizing role in the energy grids of the world. Such new solar technology, technically feasible, economically sound, and environmentally attractive, is now being refined to meet the energy needs of today and tomorrow.
Science Screen Report has been produced by Ciba Geigy Corporation with headquarters in Ardsley, New York, as part of its continuing program in support of science education.